Hello, good night, Professor.
Hello, I'm here.
Hello, how you doing?
I'm all right.
Good, good, good.
We're gonna wait for the other guys.
All right, no problem.
Hello, Professor. Can you hear me?
I can hear you.
Hello.
I can hear you. Mamadou?
Anyone could hear me?
Mamadou, I can hear you.
Anyone can hear me?
I can hear you.
Thank you. How you guys doing?
I'm all right.
Good.
We'll just have to wait a few minutes for the other guys.
No problem.
We're going to wait about 5 more minutes. So 2 more minutes, 2 more minutes, we will be there. Okay, let's get on with it. Let's get on with it. All right, I see Franz Henry. Okay, I see Mahamudu. All right, so we're going to do something very simple today. Again, I'm going to make this announcement on Blackboard. Your exam, the final exam, will be about the 16th or the 17th of December. The final exam week is from the 14th through the 20th of December. So we have about 18 minutes of silence here, so I don't know if I'm going to be able to edit this. In any event, your final exam is going to be about the 16th or 17th of December. There'll be two parts to the final exam. There'll be a multiple choice part. There'll be also a part that you have to work out problems. Now, I'm going to take the liberty of doing a lecture today on hypothesis testing for a regression model. It's not a difficult thing. The calculation of the parameters for the hypothesis test might be a little tedious, but I'm going to simplify the process so that you will see what it takes to do a test of hypothesis. But I will not take you through the tedious calculation of the standard error of the slope. I will illustrate for you what it looks like. We don't have that kind of time. But what I will do is I will emphasize your interpretation of an estimated equation and to use the estimated equation to do a hypothesis test. That will make it so much easier on you. So what I'm going to do is I'm going to offer that next week, which is December 8th, I will do another lecture that is going to really focus entirely on interpretation of different models and hypothesis testing for the slope using different examples. In that way, you will be able to essentially master that. And then on the 15th, we will do an exam review if you so desire, which is really looking at problems, the kinds of problems that you will see in the exam. In that way, you'll be able to, at least you'll be better prepared to do it. Now, if you don't want to review it, that's fine with me. That's my initial thing. So having said that, I'm going to go into hypothesis testing for regression analysis. Again, I would hope, let me just ask this question. It's a rhetorical question. If you answer it, it's fine. I hope that after the last lecture, you were able to do an estimation of a slope and an intercept for regression analysis. So we have some practical problems. If not, we could go through it again, or maybe we can go through it on the 15th, or even next week, we can go through another example so that you'll be prepared for it, because I will test you on your being able to estimate slope and intercept. Now, I'm not going to give you a spreadsheet and ask you to start from the beginning. I will give you the summaries, like summation y minus y hat squared and summation x minus x hat squared. So essentially, I'm just going to test you on being able to plug in the formulas when you are given the summations. So you're not going to go through the tedious process of working through a spreadsheet. No, you will not do that. And then we're going to learn how to more or less do a hypothesis testing without the calculation of the standard error of B the slope, but you will be required to calculate the z or the t, and also to do a hypothesis test. So having said that, let me pull up the PowerPoint slides. So I'm going to share my screen. Okay. All right. Now let's go back to the estimates that we had. Okay. Remember, we were looking at the estimation of the estimation of the cost of maintenance of a bus as a dependent variable. The maintenance of a bus depends, this is maintenance here. Okay, this is maintenance expense. We say that maintenance Y depends on age of a bus. Okay, so we did estimate that the basic cost of maintenance of any bus is about $448 per year. And then for each additional year, you should be expecting to spend an additional $15 for the maintenance of that bus, in addition to the 448. So in that case, if a bus was 7 years old, let's say 7 years, okay, then the maintenance will be 448 plus 15.59 times 7, which will give you 557. So that will be the cost of maintaining a bus that is 7 years old. Let's put this in. Just bear with me for a minute. Okay. So now the point I'm trying to get at is the following. The question that we ask in hypothesis testing for regression analysis is the following. The question is, can we say that the age of a bus significantly affects how much we spend on the maintenance of the bus? Now, remember that the age of the bus is independent. It's an independent variable. So actually, the test of hypothesis we do in regression analysis is to ask ourselves, does the independent variable truly significantly affect the value of the dependent variable? Let me say that again. Does a change in the independent variable significantly affect the value of the dependent variable? In this case, do changes in the age of the bus significantly affect changes in the maintenance expense of a bus? And so how do we go about doing that test? Okay? How do we go about doing that test? Now, the test is done using a t statistic, using a z, okay? So the z for the test, yeah, this is how we go about doing the test, and I'm going to replicate that. All right. So test of hypothesis here for the slope. Test of hypothesis for the slope. So we calculate a z, and z is b minus b hat. Okay. Actually, it's the other way around. B hat minus B divided by the standard error of B hat. Okay, so that's the standard error of B hat, which I'm not going to go through the process of calculating, but I'll give you the formula for it. This is how to calculate the standard error of B hat. And you can implement it if you want. I might implement one for you, and so as to show it to you. Not today. I will not implement it today. I have it out there. Okay. So this is how you calculate the standard error of B hat, but we're not going to go through it. Okay. We're not going to go through it. So now, if I give you B hat and give you B, the question then I give you the standard error of B hat, you can calculate the a Z and then use the decision rule. So now the hypothesis is that B is equal to 0, okay? Which means that the slope equals to 0. And what is the meaning of that? The meaning of that is that the independent variable does not significantly affect the dependent variable. Or you can say that changes in the value of the independent variable, okay, and put it another way, changes in the value of the independent variable do not significantly affect changes in the value of the dependent variable. So that is what the null hypothesis says. Okay, that's what the null hypothesis says. Now, the alternate hypothesis is that B is not equal to 0. All right, that B is not equal to 0. What does that mean? Okay, which means that the slope is not equal to 0. And if the slope is not equal to 0, you are saying then that changes in the value of the independent variable do significantly affect changes in the value of the dependent variable. That is to say, if a bus gets older, or you can say in another way, the older buses incur a higher cost of maintenance than newer buses. Okay, this is something that, again, it's a question you have to answer through hypothesis testing. I know very often students will say, well, of course it does. Well, that's a theory, okay? And you realize what hypothesis testing does. What hypothesis testing does is that it tests a theory. It tests an idea. That is the whole idea of hypothesis testing. You use hypothesis testing to test an idea, to test a claim, okay? Like I said, it's designed to test a claim about the characteristic of a variable. And here you are testing the claim that older buses cost more to maintain than newer buses. Okay, so here the independent variable is age of the bus. The dependent variable is the maintenance expense of the bus. So now we're going to look at one example. Okay, we're going to look at one example, and I might pull up other examples, and then I'm going to post them for you for continued illustration. Now, here is an example. This example is about food expenditure and family size. Okay. Now, I'm going to ask you a question. I'm going to ask you a question. One of you give me the answer. Any of you give me the answer. So I was ask you this question. Which is the dependent variable and which is the independent variable here? Mahamudu. Food expenditure and family size. Which is the dependent variable and which is the independent variable here?
Which one is the dependent and which is the independent?
Yes. When you look at food expenditure and family size.
Okay, which one you want to know? Which one is independent?
Yes, which is the independent variable here? Which value depends on what other value? On the other value.
Which one depends? I would say family size.
Family size depends on how much money you spend. So I guess.
Oh no, food. Okay, no. I mean, family size gonna be independent.
That's correct. That's exactly what I'm looking for. Okay, you know, the bigger the family, the more money you spend on food. You get the idea. Okay, so how much you spend on food depends on the size of the family. You get the idea. Okay, so here we are doing an estimation of the relationship between family expenditure and food expenditure and family size. Okay, let me make a correction here. All right, so now we estimate the model using the methods that we know. We estimate the model using the methods that we know. And so we estimated this model to be Y, which is expenditure, okay? And the expenditure on family size is about $3,379 per year plus 41.4 cents for each additional member of the family. Okay, so I'm going to say size of family here. All right. So this is the model that we get from the estimation that we know how to do. Okay. And so, in fact, next week I'm going to set up problems that look like what I'm going to give you an exam so that you can practice. And I'm going to announce this so that nobody will say they were caught off guard. Okay? So we estimate the model. Now, when we estimate this model, the model is right here. It's a printout. So I'm going to give you the printout. Okay? I'm going to give you the printout. And this printout shows you is what I write out here. So you have to learn how to use this printout to write out the equation of the model. Okay? So you write out the equation of the model. So the constant amount of money, I mean, essentially, this is simply saying that if there's no member in the family, you still spend this kind of money. Well, not exactly, because this is a model that is not complete, but it's used as an illustration. Now, but it says then that for every additional member in the family, you spend an additional 41 cents, um, you know, for food. Okay. And the standard error of B is 0.048. So I'm going to write this model out. I'm going to write that model out so that you can see how to do a test of hypothesis. Now, remember when you're doing a test of hypothesis, what are some of the steps? Okay, so let's write out the model. I'm going to write it out. Okay. Okay. And the standard error of B hat is 0.048. And so we're going to go through that whole process right now. Okay. Okay, hypothesis test for food expenditure and family size. All right. So now we estimate the model as y is equal to 3.379 plus 0.414 times x plus e. All right. So we have the standard error of b hat. I'm going to take this and make life easy for myself. The standard error of b hat for this problem is 0.048. All right. Standard error of b hat is 0.048. Okay. Our hypothesis test, the null hypothesis, is that b hat is equal to 0, which is equal to 0, which means what? Which means that family size in simple language does not matter. Okay. So you can say family size does not affect amount spent on food. So regardless of family size, everybody spends the same amount of money on food. All right. That is the null hypothesis. We're not saying that it is true. We're going to test out if it is true. Okay. We're going to test out if it is true. And the alternate hypothesis Okay, the alternate hypothesis is that family size does matter. Okay, okay, family size does matter, which means to say does significantly affect amount spent on food. This is the null and the alternate hypothesis. So let us now select, okay, and let us say that for this problem, our sample size is equal to 46, even though we don't need it here because we're not calculating the standard error by ourselves. And so our level of significance is, let us just take a simple example, 0.005, which means that Z star, our critical Z is 2.576. All right, our Z star is 2.576. All right, and you know the drill from here. So let's try to fit this problem into one frame so that we can see the entire process at once. Okay. Are you able to see what I'm doing? Hello, guys. Hello, hello.
Yes, Professor.
You can see what I'm doing?
Yeah.
Okay. All right. All right. So we have the null hypothesis, which says that B is equal to 0, not B hat. B is equal to 0 because we're testing for the true B, not the estimated B. Okay. We're saying that B is equal to 0. Family size does not matter. Okay, which means that family size does not affect amount spent on food. And the alternate is that family size does matter. And so family size does significantly affect the amount spent on food. Okay, to correct the grammar. All right, so, and we calculate Z like we do all the time. Z is the hypothesis minus the true value minus the hypothesis. Okay. The true value minus the hypothesis divided by the standard error of B hat. So how do we calculate this? Okay. So B minus B hat. Okay. And so this is 0 minus B hat. And B hat is 0.414 divided by the standard error of B hat, 0.048. And so what we have, we use the absolute value. Can somebody help me find out what Z is, the calculated Z? Hello?
We're on it. We're on it.
All right. The absolute value we're going to use.
Sorry, Professor, I just heard it.
It's negative 8.625.
8.625. Okay. And so, decision rule. Decision rule is what? If Z is greater than or equal to Z star, okay, let's see. Then we reject the null hypothesis. Okay. If Z is less than Z star, we cannot reject the null hypothesis. All right. So what is your decision for this problem? Hello, people. What's your decision?
We go. That one affects that one. That one affect because it's inferior to Z plus.
Wait. First of all, what I want to hear from you is to reject or not to reject the null hypothesis.
Yeah.
So in this case, do you reject the null hypothesis or do you not reject it?
First step, we
So if Z is greater than Z star, you reject the null hypothesis. What was your null hypothesis?
is 8.625.
No, that's not your null hypothesis. Your null hypothesis is right there in front of you.
The family size does not matter.
Yeah, that's your null hypothesis. So the question is, if Z is greater than Z star, right?
Mhm.
You reject the null hypothesis. If Z is less than Z star, you do not reject the null hypothesis. So in this case, do you reject or not reject the null hypothesis?
I reject it because it's greater.
What is it? What is it you're rejecting?
The Z.
What is it you're rejecting?
The hypothesis
You are rejecting the null hypothesis that
the family size does not matter.
that's correct.
Okay.
So
I
what
get
is
it.
your conclusion?
So my decision, I don't know. Since Z is greater than,
Z star.
no, sorry. Since Z star is greater than
So since Z is greater than Z star,
Z star, then I reject the hypothesis
that
the family size does not
Sorry,
matter.
guys.
that's correct. Reject the null
Okay, I get that
hypothesis
part. Thank you.
that family size does not matter. Okay. Family size does not matter. That is what you are rejecting. Okay, you reject that null hypothesis. Okay, so you reject the null hypothesis that family size does not matter, and therefore you conclude that family size significantly affects the amount that the family spends on food. You get the idea? Hello, guys.
Yes.
So you get the idea?
Yes,
Okay. All right. So I'm glad you got this idea. And you know, the homework assignment for this is really due on the 12th of December, because the other assignment is still due in about 2 or 3 days. So next week on the 8th, I'm going to really focus on this process so that we will master it, because your exam is going to be a fairly long exam. It's going to be about 3 hours.
So we have another example before the assignment is due.
Yes, so
Thank you.
that's we're going to spend throughout next week. I'm going to bring a whole bunch of examples and we're going to solve through them.
I appreciate it.
All right. Okay. So I mean, I'm not going to actually post today's lecture, okay, because I recorded a whole lot of silence, about 15 minutes of silence here. I mean, it may not matter. I mean, all you have to do is to scroll through it until you hear something. But the point of the matter is that next week we're just going to focus on this. We're just doing examples where you have the equation, the estimated model. You're going to have the B hat. You're going to have the standard error, and we're going to look at different several problems. We're going to spend all that time looking at several problems, and I need for you to master this before the exam. You're also going to estimate the slope and the intercept by using summary statistics rather than going through a spreadsheet yourself. So we're going to spend a lot of time on that too. In that way, you're able to prepare properly for the exam. You understand that?
Yes. Professor, can you still post this lecture?
Yeah, I will post it, yes.
Thank you.
I will post it. It's just that you're going to have to scroll through 15 minutes of silence. And all you have to do is to move the bar until you get to where I begin to talk. All right?
Yes.
Okay. So I'll see you guys next week. Okay. And if the class cares, if you ask for an exam review, we'll go through an exam. But the point of the matter is that, well, I mean, if I have at least 4 or 5 students, I will do an exam review. If I don't have 4 or 5 students, I will not do one.
I understand. That makes sense.
All right. Okay.
Okay.
All right. Good night.
Okay. Good night, Professor. I'm gonna email you.
Okay. All right.
Yeah.
I'm waiting for your email.
All right. No problem. Thank you so much.
Good night.